Well, hi there. I'm sitting in a classroom today, so if it's a little bit echoey here, please forgive that little bit of inconvenience. But we're going to talk about ellipses and hyperbolae, and it is a fascinating subject, so let's go and have a look at it. Well, did you know that a circle is really a special case of an ellipse? Yes, I heard you gasp, it is. So if we started with, say, the well-known equation x squared plus y squared equals r squared, that is a circle and it's got a centre at the origin and the radius is r. Now, let's just do a little bit of surgery on that and divide both sides by r squared. We're going to get that, aren't we? Yes, we are. Okay, it's still a circle. However, now if we write that in a more general form, as x squared over a squared plus y squared over b squared. So in other words, we're saying that these terms don't have to be the same anymore. Then a is not necessarily equal to b. Then this is the general form. Well, not quite as general as the general form, but that is basically we've now moved away from a circle to the concept of an ellipse. So this a is it's not called the radius anymore. It's called the x semi-axis, and the b is called the y semi-axis. Okay? Yes, it's fascinating. It's a bent circle, a squashed circle. Okay, but of course if b equals a, then of course it is a circle. So a is the x semi-axis, b is the y semi-axis, and if a equals b, yes, you've got a circle. But a circle is a special case of an ellipse, yeah? Okay, so if we're generalising still further, for a centre not at the origin but at h and k, we have this formula here. Var-B, that's the formula for an ellipse in its most general form. Centre is h and k, x is the x semi-axis is a and the y semi-axis is b, alright? Now, some examples, let's do some. We've got this beast, we've got to sketch that thing. So what can we make of that? Well, oh, there's another one. Good heavens above. All right, we'll do both of them. There's A today. Hooray. We've got an ellipse with a centre at 2 and 3. Are you agreeing? Yes, very good. The x semi-axis is 3 and the y semi-axis is 4. Just so we can get it in proportion. So it's taller than it's wide, if you like. Yeah. So now we'll do the x-intercept, because you have to do the intercepts when you're plotting these things, sketching them. So for the x-intercept, we know that y equals 0. So let's make it 0 and see what we get. Have a look. Do you agree? Good. Now, okay, so taking 9 over 16 from both sides, we get x minus 2 all squared over 9 is 7 over 16. So let's multiply both sides by 9. Looks okay. Therefore, we can take the square root of both sides and then add 2 to both sides. We're going to get x is 2 plus or minus 3 root 7 over 4. So that'll get us both of these coordinates of the x-intercepts. Yes, very good. Now let's do the y-intercept. That'll make x equals 0. Substitute that in. And do we get that? Looks right, doesn't it? Yes, from up here it looks right. Now let's work out what we're going to do with that. Very good. Yes, it looks right. So therefore, y minus 3 all squared equals that. Now let's do the same thing as we did before with the x. We're going to say y is going to be 3 plus or minus 4 root 5 over 3. There are y-intercepts. There are our y-intercepts in coordinate form. Okay, now I think I've got the graph coming up here. Yes, there we go. There she is. That's the centre. This, oh goodness. That looks like 0, but it isn't 0, okay? It isn't 0. So there the x-intercepts, that one, and that one. It's very close to 0, but it's not. That's right for the x-intercepts, and for the y-intercepts, what have we got? That's another one that looks like 0, not quite on 0. And that one there, and everything looks beautiful, doesn't it? Yep, and it is taller than it is wide, you can see. Yep, there you go. How nice, how beautiful. What's this one? Okay, now, when you look... I better not get ahead of the presentation. The coefficients of the x squared and y squared terms are different. That's what I was going to say. And when you see that, you know that if those coefficients are different, it's not a circle, it's an ellipse. Okay, that's what you look for. Okay. Now in that case, we're going to have to complete the square for x, because we've got a middle term here, which needs to be put in a linear bracket with an x and squared somehow, okay? So I'll show you. We're going to do that. Agree? Yeah, you do? All right, that's good. Now we're going to complete the square inside that bracket. Yes? Now we're going to get the minus 16 out of the bracket, right? Yeah, that's good. But we've got to remember to multiply it by 3, otherwise we're in deep trouble. Okay, right? 3 times minus 16 is minus 48. Yes, now we can basically express it like that. We've got our completed square. And now we're going to divide both sides by 12. And we're going to get that. And we've got ourselves an ellipse. If ever I saw one, guys, that's an ellipse. And the centre is at minus 4 and 0 for the y, right? Yes. Oh, minus 4. Wait a minute, I'll fix that. Okay, that's better. And minus 4 and 0. And what else have we got here? Yes, a is 2 and b is 2 root 3. Okay, so let's see which one's bigger. 2 times, that's about 1.7, so it's about 3.4. So it looks like it's the b is a bigger number than the a, so it's taller than it's wide. Okay, just to get sort of a sense of proportion. Okay, right. For the y-intercept, when x is 0, we're going to get, does that make sense? Let's have a look. Yes, that's right, that's going to make sense. Yes, that's good. Therefore, oh, goodness gracious, there's no y-intercept. No y-intercept? That's impossible. So that's okay. So let's do the x-intercept now. When y is 0, we're just going to get this term here will be 0. So therefore we'd get x plus 4 all squared equals 4. And therefore x plus 4 would be plus or minus 2. That's right. Therefore x would be minus 2 or minus 6. Very good. There are our x-intercepts, right? This one and this one. Very excellent. Oh, look at that. Huh. Looks good, doesn't it? Looks great. Yes, there's our intercepts there. There's our centre, and it is taller than it is wide. So I'm pretty happy with that. What about you? Great. Let's have a look at hyperbolae now. That's a Latin word, and the plural of hyperbola is hyperbolae. Okay. Equations now. Hyperbolae take the form. They look exactly like ellipses, except there's a minus in here instead of a plus. So that's what you've got to watch for. If it's a minus, if there's a minus here, or if there's a minus there, one of them's got to be a minus instead of both being plus for an hyperbola, right? Now that one there has that particular shape. The black bit is the actual curve. The red ones are just the asymptotes, right? That hyperbolae have asymptotes. So we've got to deal with that as well. That's that one there. Now, the positive term gets the intercept. So this has got x-intercepts. There's an x positive term there. Did you get that? This one here is the other way around. That's got the y term is the positive one. So that means there'll be y-intercepts. And that's a graph of that looking like that orientation, okay, where the curve is the up and down, whereas up here the curve was left and right, yeah? Yes, the positive term is the one that has the intercepts, yes, guys? Let's deal with the asymptotes now, that's very important. So if we took that graph there, that's one that's centred on the origin, okay, just to make it a little bit simpler for this analysis, okay, and it's got the A there and the B there. What would the asymptotes be? Because you do have to quote the equations of the asymptotes, yes? Right, so we've got to work out what the jolly asymptotes are. So let's do that. Solving for y, let's do that. Now that's what you get. If you fiddle around and juggle the algebra, that's what you get when you solve it for y and take the square root of both sides. Okay, now, here's the deal. As x approaches infinity, this term here becomes absolutely astronomical, and this term here is like a pimple in a pumpkin, well, a micro pimple on a gigantor pumpkin. It hardly makes any difference at all, okay? So, what happens is, as x approaches plus infinity or minus infinity, this term completely dwarfs that, well, hang on, where are we? Down here. This term here completely dwarfs that term there. So if you neglect that term there is what's keeping the graph off the asymptote. That's the term, because it's getting closer and closer and closer to the asymptote as x gets bigger and bigger and bigger and bigger in the positive or the negative. And if you actually neglected the effect of that -1, you would get the asymptote. And that's what I've gone from there to get that asymptotes, those asymptotes. Yes? Pretty neat, huh? That's what you do. Now, these are the asymptotes. Yes, they are. Now, to find the asymptotes easily, very easily, you do the Wolfman quick and dirty technique. You basically just neglect the 1. You don't need to solve it for y. Just look at this and just say, goodbye, Mr. 1. We're not dealing with you, because if we don't have the 1 in there, we do get the asymptotes. Just the same as down here, we neglected the effect of the 1 to get the asymptotes when we solved it for y, didn't we? Okay, so I hope this is clear. So what you do, you've got, say if you had this equation here, right? This one. To get the asymptotes, you would just make that 1 a 0. That's what you would do. Okay? And you would get that, and then you would immediately solve it for that. Okay? That's what you would get. Once you took the square root of both sides and juggled around a bit, that's what you would get. And they are your asymptotes, right? So, the asymptotes would cross where x minus 2 is 0, in other words, where x is 2, and where y plus 4 is 0, in other words, y is minus 4. That's where they cross, okay? Yes, crossing swords at that centre point, and that is the centre point of the asymptote where of the hyperbola where the asymptotes cross. All right, guys? Now, yes, you do have to calculate all of the x and y intercepts in exact form. Yes, I know, I heard that groan. I groan with you. And you don't have to calculate the intercepts of the asymptotes, but you do have to get them looking right so that they are in the correct place on the graph, including where they cross the x and the y axis, for just the sake of correctness and correct looking proportions, all right? Oh, what have I written there? So, you do have to find the equations of the asymptotes, yes, and you must observe asymptotic behaviour, oh yes. You must always make sure the curve is approaching the asymptote when you've got increasing values of x. That is correct, that looks good. That is totally wrong. Look how that's bouncing back, like it's going to zoom back out and into outer space, getting further away from the asymptotes again as x increases in the negative, and over here, conversely, as x increases in the positive, it's starting to arc away, bend away from the asymptotes. That would lose you marks, guys. Please take a ruler into the exam and just make sure that you get that bit right, okay? It's not worth risking it with freehand, okay? Yeah, that's wrong. Absolutely wrong. The curve must always approach the asymptotes as x increases in the positive or the negative and not turn away. I hope you heard that, and sorry for the rant. Okay, now we're going to sketch these two hyperbolae. You'll note that they're exactly the same, except one's got the x as the positive term and one's got the y as the negative term. Okay, so if this is the positive, I'm expecting that to be a left and right branch hyperbola. If y is positive, I'm expecting that to be an up and down branch hyperbola. The asymptotes will be the same. Yes, they are. They're the same in both cases. So, these are going to be the asymptotes. There they are, all right? The centre is at 2 and minus 4. X is 2, where x minus 2 equals 0, and minus 4, where y plus 4 equals 0. And that's where the asymptotes cross. That is the centre of the hyperbola. Okay? That's what I was saying. Now, NB, what have I written here? For A, yes, the shape is a left and right branch. And the A, oh yes, this is very important for you to get this. The A term, that's the squared term under the, here. The A squared in this case is 16, so A would be 4. So in that case, 4 would be the distance horizontally from the centre of, that's where the asymptotes cross, to its narrowest distance between the two branches. That is the distance horizontally out from the centre to where the curve basically hits that horizontal line that you're drawing out from the centre, either left or right. It'll be 4 units exactly, horizontally, to the left and to the right from the centre where the asymptotes cross to where the curve hits that horizontal line. That's what I'm trying to say. That horizontal line will give you the distance calculated in that way where the hyperbola is at its narrowest point. That is the narrowest distance between the two branches. Hope that was clear. It's a little bit hard to describe, but I'll show you when we get to the end, okay, when I'll show you the graph of the hyperbola. For B, that's an up and down shape, and the B term, in this case, that's root 12, right? Root 12, that'll be the distance vertically. Oh, well, that's for B, actually, for this one. Where are we? Over here. Yeah. It's the distance vertically from the centre, that's where the asymptotes cross, to the curve at its narrowest distance between the two branches, right? Yeah. Don't worry, if you don't get that, I'll show you when we get to the end, right? No problem. So that was 4 units in that case, and this one was root 12 or 2 root 3 units in that case, yeah? All right, now let's go for it. Here comes all the tedium now. Here's A. X-intercept means y is 0. Therefore, we get to that, do we? Y is 0, yes. Let me just work that out. Y is 0, 16, yeah, 4 over 3, that's right. Yes. So therefore we get that, and therefore we get that, and therefore we get that as our x-intercepts, right? Now the y-intercept would be when x is 0, so let's do the same old for that. X is 0. Yes, that looks all right. Yes. A problem. We have a problem. That can't be negative because you're taking the square root. You can't take the square root of a negative number. So that means we've got no y-intercept. Okay? Right, so that's that one there. That's done. Now we'll do the same old for B. And same procedure. Now the y-intercept would mean x equals 0. Okay, so let's just see what we get from that. Yes. Yes, I agree with that, and yes, I agree with that. Now, yes, that's right, 3 5s are 15, multiply both sides by 12, you'll get that. Therefore, y is going to be that beast, right? That's the y-intercepts. Now, the x-intercepts, that means y is 0, of course. Now, we're going to make y 0 now. Okay, so what do we get there? Yes, I agree with that. That's just basically 4 over 3, that thing. So what do we get now? Oh yes, we actually are going to get some x-intercepts here. This is good. So what do we get? 16 over 3. Yeah, that looks all right, doesn't it? Yes, therefore x is going to be that. How interesting. So we got 2 x-intercepts out of part B. Yeah, the up and down branch hyperbola. So, all right. So I think we need to go and have a look at the graphs now. Are you ready? Ready, set. Whoa! Look at this. What a monstrosity. Actually, it's quite beautiful, really. Here's the centre point, right? Here's the centre point here. Yes, at 2 and minus 4. Now, what I was trying to say before was with the left and right branch hyperbola, this horizontal distance from the centre out to there is the A term under the x, which was 4. Right? For the up and down branch hyperbola, this distance here from there upwards with a B term, 2 root 3 or root 12, that's what that vertical distance is there, to the hyperbola at its narrowest point, right? Yeah, narrowest point there, vertically. Narrowest distance between the branches vertically is what I'm trying to say. Do you get that? So let's have a look. There's that's the left and right branch hyperbola equation. There's the up and down branch hyperbola equation, and here are the 2 branches of the asymptotes. That's the positive gradient branch, and that's the negative gradient branch. So everything's looking pretty cool, I think, don't you? Looks pretty marvellous. I think that might be the end. Yes, and the end is your friend. So go forth and conquer your ellipses and your hyperbolae, guys, and do lots of practice, and your skills will absolutely soar like the eagles. And we'll see you next time. Bye for now.